Hello, everybody. Welcome to this webinar hosted by JetBrains. I'm your host, Nafil Islam, and today we're going to be talking to Abby Carey from Google. Abby is going to be talking about developing Flask applications on Google Cloud. So,
Yep.
I'm not going to spend too much time talking about this. Especially what we can go talk about is if you have any questions, please ask them on the side panel. There's a little chat pane on the YouTube window. And also, this talk is being recorded. So we get questions about this all the time. Is it going to be recorded? Yes, it is. So, folks, without much further ado, let me just pass it on to Abby, who has a wonderful presentation for you today.
All right, as Nafil mentioned, I'm going to be talking about developing Flask apps on Google Cloud. And I won't be digging too deep into Flask. I'm mostly going to focus on how you can extend a Flask application and connect it to Google Cloud service products and services. But let's get to it. So my name is Abby Carey, and I'm a developer advocate for Google Cloud. And I primarily focus on dev tools and right now, that's mostly a IDE plugin called Cloud Code. And I've been dabbling a bit in the Python world as well. And follow me on Twitter at Abby Applebee's. So what are we going to be covering today in this hour? First, we're going to take a look at Cloud Run and Cloud Code. Then I'm going to show you one of our sample websites that is built with Flask and SQL Alchemy. And I'm going to connect that to a database in the cloud and also secure it with Secret Manager. Then for my second sample, I'm going to show a Cloud Run service that is triggered by PubSub. So when a message gets published, it will invoke my Cloud Run service and do something. And then we're going to extend on that sample and make it an async image processing service where someone can upload an image to a storage bucket. My Cloud Run service then does some processing on that image, and then we upload it to a different bucket. So let's talk a little bit about serverless and Cloud Run. You've all probably heard of the word serverless before. It's like, the new hotness and all that. But Cloud Run is one of our serverless offerings. And looking at this serverless responsibility pyramid right here, with Cloud Run, since it's managed, all you have to worry about is your application development, which is just your code, and monitoring your performance. Cloud Run handles everything else, including scaling when you get a ton of traffic or no traffic, and it also handles your physical servers, hence the serverless. Okay, so what does Cloud Run give you? So Cloud Run is container-based and lets you deploy stateless HTTP containers. It's also super fast. So when you go to build this, it's going to deploy in minutes or seconds, not hours. You also get the flexibility of configuring your own custom domains. So when I deploy to Cloud Run, I'll get a big, ugly URL, but you can make that URL whatever you want. It also supports custom binaries. So any language is fair game. And also any library as well. And because it's container-based, it's portable. But one of the coolest features, I think, is that when no traffic is coming in to your Cloud Run service, it scales down to 0, which means you're not paying to keep this service up and running when no one's even visiting. So let's talk about some Cloud Run use cases. The first one, and probably the most simplest one to grasp, would be a website. So all I have to do is pick my favorite tech stack, then containerize it and deploy it to Cloud Run. And then I have the option to connect it to a Cloud SQL database. Another example, which is pretty cool, is using Cloud Run as a data processing pipeline. In this diagram here, if I have a CSV file and I upload it to cloud storage, I can set a notification trigger, which then triggers my Cloud Run service. Inside my Cloud Run service, it can do some processing of that CSV, turn that lightweight data into structured data, and then I can then store it into BigQuery for analysis. Then there's automation. So Cloud Run can be tied in with your automation using Cloud Scheduler. So what Cloud Scheduler does is I can set how often I want my Cloud Run service to kick off. So in this diagram here with Cloud Scheduler, I can have my Cloud Run service kick off every month. And then my Cloud Run service will get customer data from a Cloud SQL database, use LibreOffice that's packaged inside it to then process that customer data into a PDF and then store that PDF in a cloud storage database. So let's take a look at Cloud Code, which is the dev tool that I'm going to be using today to work with Cloud Run. Cloud Code is an IDE plugin that automates development workflows for cloud-native applications. This plugin is composed of a bunch of tools that assist you in a variety of workflows for GCP, Cloud Run included, and it integrates right into the UI of PyCharm and other JetBrains IDEs. And I'll show you that in a little bit. It also automates repetitive processes seen in your inner development loop. And overall, it's just here to save you time and make you more productive. So this might be what your development process looks like. In your inner loop over here, this is all about you. You're coding up your feature, you're building it, you're testing it, you find a bug, and you rinse and repeat over and over and over again. And then finally, you're going to push it out to the outer loop, where it begins that whole CI/CD process of integrating and releasing to the world. Cloud Code is all about this inner loop here. We're going to be focusing on how that is much more streamlined with Cloud Code. So who gets to use Cloud Code? Well, PyCharm users can use it, as well as IntelliJ, Golang, and WebStorm. Pretty much if you're coding in Java, Python, Go, or Node.js, and you use an IDE, we've probably got you covered. But you do need to have Docker installed, and also the Cloud SDK. Cloud Code automatically installs that for you a lot of times, but there could be permissions set on your computer that will block it from being installed. So let's take a high-level look at what Cloud Code brings to the table when developing Cloud Run services. First, it makes getting started quick. So we already have Django and Flask samples ready to go. All you have to do is create a new PyCharm project, click Cloud Code, and pick one of those Cloud Run options. And it's a service that it's an application that's ready to be packaged and deployed to Cloud Run as a service. And the Cloud Code team manages these samples, and they show best practices. Overall, it's a good base to get started with Cloud Run and containers in general. Then it helps automate the repetitive tasks of building, pushing, and deploying. And it condenses these repetitive commands into a simple UI. All I gotta do is click one play button and it's going. And what's also cool about this whole pipeline is while I can deploy to the cloud, I can also deploy to a Cloud Run emulator running locally on my machine. And with this, I can test my Cloud Run service in a production-like environment before I actually have to deploy to production, so there aren't any surprises. And then we have Cloud Code has a watch mode feature, which enables auto redeploys on changes. So if I deploy my service to my Cloud Run emulator, code up some changes, hit save, it automatically triggers a build and redeploy to my emulator, which takes 30 seconds or so to a minute, and then my changes are there and I can view them quickly. And finally, it leverages cloud APIs. So this overall, the goal is to reduce context switching by bringing cloud APIs into your IDE. We have a nice little UI to enable an API quickly and get the docs you need, install libraries, and all that. Overall, Cloud Code's a tool that you need for your IDE, so it just reduces context switching is the goal. So now let's take a look at those 3 demos I mentioned. But before I do that, I want to mention service accounts. So service accounts are part of identity and access management for Google Cloud. Use them when running workloads that you don't want tied to the lifecycle of a human user. And ideally, every Cloud Run service has its own service account. And a service account represents a non-human user that needs to authenticate and be authorized to access data in Google APIs. You can see a service account as both an identity and a resource. As an identity, I can grant roles on my service account, roles and permissions. So if we look at this picture I have here, I have a service account that I have assigned the storage.objectCreator permission. And with that, my application, my Cloud Run application that is tied to the service account is able to create cloud storage buckets with that permission. Yeah, so overall, you can grant your service account roles, which have a ton of permissions underneath them, or if you want to get fine-grained, you can grant them individual permissions. And I've created two service accounts for my demos. And I'll talk about them more when I get into it, though. So the first example I'm going to show is a website. And this website is built with Flask and SQL Alchemy. And all it is a tabs versus spaces site. You can vote for tabs, vote for spaces, and it'll write to a database. And then down below in recent votes, I will display the 5 most recent votes to this database. Okay, so let me go ahead and open up PyCharm and show you what I got. So this is my Flask website. And before anything happens, I'm going to set up a database, and I'm going to set up a SQL Alchemy connection and then create a database with it, and also set up a session factory so that I can establish sessions and commit to my database. In this init connection engine function here, I have set some configurations for my SQL Alchemy engine, including how many permanent connections I can have. And then this is where I'm going to be doing some interesting stuff. So this is the init Unix connection engine. This is where I'm going to be establishing a connection with the SQL Alchemy engine to my Cloud SQL database. And then in index, all I'm going to do is be rendering a template and giving it the context from my database. And the context, which is get index context, if I go down here, all I'm doing is creating a session and then I'm querying my database and seeing what's going on in there and displaying it, including finding the 5 most recent votes so that I can display that at the bottom of my website, and counting up how many tabs and spaces votes I have so that I can calculate who's the winner. All right, so, and then we're going to return that. And then when someone clicks a vote, let me go over to my template here. This is the interesting stuff going on. I have a bunch of HTML above, but I am going to add a listener to those 2 buttons so that I can then save my votes back in app.py and save vote. I am going to determine what type of vote it is and then use my session to then add the vote to my database. And in my models file, I create a votes class here, which, with ORM, I can make a votes table that I can access from Python here. And the votes table has timecast, so the time I place the vote, and the candidate, which would be tabs or spaces. And then I have my create database function over here too. Okay, so now I want to start working with Cloud SQL. So behind the scenes, I have already created a Cloud SQL instance. And a Cloud SQL instance is a virtual machine in the cloud that holds all my databases. But to access that Cloud SQL data, my Cloud SQL connection, my Cloud SQL databases, I need a tool called Cloud SQL Proxy. And I'll go ahead and show you that. Cloud SQL Proxy. So I don't know if you can see that. Maybe I can zoom this in a little bit. All right, so Cloud SQL Proxy. Cloud SQL Proxy allows me to connect to my Cloud SQL databases locally. So it establishes a secure connection that I can connect through. And everything's encrypted with TLS. And all you gotta do is go to this site here, and then I will pick between, you can select your operating system, download the proxy, and then make the proxy executable. But I've already installed this. So I'm going to go back to PyCharm. Okay, and I'm going to open up my terminal and, oops, I already ran it once. And now I'm going to run my Cloud SQL proxy. And I'm going to use this command here. It's pretty small. I don't know how to zoom it in, but with Cloud SQL proxy, I'm going to pass it in the instance name of my Cloud SQL instance. And then I'm going to set TCP equal to 3306 for our port. And then I will kick it off. And now it is ready for new connections. But I want to connect PyCharm. Like PyCharm, I have the PyCharm Professional Edition, and I have this databases tab over here. And I want to check out what's in my database right now. So what I'm going to do is hit this plus here, data source, MySQL, and let's connect through this engine now. So localhost. So I've already created a database, and it's called VotingDB. Inside of VotingDB, I have a user, and the user's name is user, and the password's name is password. Very secure, very safe. And now I'm going to test that connection. And ideally, what will happen? Oh, over here, we see some action going on. A new connection was established, and then it closed it out because we were just testing it. Now I will hit apply. Okay. Okay, so now I can select, now it looks like it's all connected and good, and I'm going to pick my VotingDB schema to display. Okie dokie. And in VotingDB, if I open it up, I already have a votes table in here because I've ran this service before, but let's take a peek at what's in there. So here you can see a bunch of tabs and spaces I've logged while testing this service. And yeah, I'm gonna leave this open though, because I'm gonna be playing around in here. So now I've connected to my Cloud SQL instance with PyCharm, but how am I gonna do it from my application? So what I'm going to do is I'm going to go up to that commented out here. Okay, so I'm going to create my SQL Alchemy engine now. And I'm going to, there we go. So I just use a lab template to fill that in. So my driver name, first I need to give it a dialect, which is MySQL, because this is a MySQL database. And then I'll be using the PyCharm, not PyCharm, I'll be using MySQL. And then my user is user, my password is password, and then the database is VotingDB. Now I'm connecting through a Unix socket for this instead of through the Cloud SQL proxy. And that's because while Cloud SQL proxy works great locally, it won't, what I configured here to make it work with that won't work once I deploy it to production. So by using a Unix connection socket, it works both locally when I run it in Cloud Run emulator and when I finally deploy it. So I don't need to edit my code twice. All right, and this Unix socket is inside of my Cloud SQL instance, and so that's what I'll be connecting through. Okay, so now I'm gonna fill this in, db socket dir, and then my Cloud SQL connection name. All right, that's looking good, I think. I'm gonna hit save. All right, and now I'm gonna use Cloud Code to run this in the Cloud Run emulator. I've already created a configuration for that, but I'll just show that to you real quick. So by creating, we have these templates in here. We got Cloud Code, Cloud Run. I have already set one though and I've named it CR local. And then here I can specify the service name that I'm going to be going to. I'll call it new CR service. And I will, so to better emulate running in Cloud Run, I'm going to give it a virtual CPU. I'll just set it to 1. And I can specify environment variables, and I already popped in my Cloud SQL connection that we're going to be connecting to, and my service account. And this service account, the roles that I've given it roles so that it has a Cloud SQL admin role, so that I can have total control over my databases. And I have gave it a Cloud SQL connection role so that I can connect to it, my service can connect to it, and I've given it a secret manager accessor role, which will allow me to access secrets once I store my database credentials in them. And I'll show you that in a little bit. And we will be building with Docker, and we also support building with build packs, but I don't have a proc file on here. So I'm just gonna hit apply. Okay. Oh, and actually I forgot to specify I forgot to pass in my configurations, and that's db_config. All right, close one. And now I'm gonna try and run this in the emulator, and I'll hit play. And this takes a little bit, so I guess I'll just sit here for a little bit. And we get this output down here. Right now, it's just preparing the Cloud SDK, and it's starting with a Minikube cluster. And on Minikube, that's where we are running this Cloud Run emulator. But you don't need to worry about Kubernetes. Yeah.
In this quick time while it's building, we have a question. Does Cloud Code work on PHP Storm? And do you have PHP demos?
We do not support PHP, unfortunately. Yeah, we support, so we just Python, Go, Node, and Java. Those are ones, and a little bit of C Sharp.
Awesome. And can we have access to this code later on?
Yes, we can. I'm going to have a link at the end of in my final slide, and I have a little shortened link so you can get access to all these samples.
Awesome. All right, Abby. I'll just head back and we can get back to your presentation.
Yeah, sure thing. So right now it is building and deploying to my Cloud Run emulator, and it looks like it's done. So let's just hope. I'm hoping, nervous. Oh, crap, I got an error. Okay, so going back to PyCharm, let's see what we got. Can't load plugin, SQL Alchemy dialects. Oh, PyMySQL. I forgot an L. I forgot an L up here. So I'll put an L in. But this is a good opportunity to look at Cloud Code's iterative development. So when I hit save, it just triggered a rebuild, and now it's redeploying to my emulator. And we are deploying. Watching for changes. All right, looks like it deployed. Let's go open it back up. Give it a refresh. Woo, okay, good. So this is my Cloud Run service, my little Flask website running on my Cloud Run emulator. And let's go ahead and see if it works with my database though. I'm gonna place a vote for tabs because tabs is superior. Got 18, so 18 votes. Let's go ahead back to PyCharm and then go to my votes table here and give it a refresh. Right now we're at 29 rows. And if we get 30, we know we're good. 30 rows. Going down to the bottom here, I see my tabs. My vote for tabs, which is great. Okay, so that's looking good locally. I'm gonna go ahead and shut that down. Now going back to the app, my app.py, there was this problem right here. My database credentials are looking very naked and exposed right now. Probably not the best thing. So what I'm going to do is I'm gonna store these credentials in Secret Manager. And Secret Manager makes it super easy to access secrets from your code. So first, I am going to store these in secrets with Cloud Code. I'm going to go to the Secret Manager panel here that Cloud Code added. And I've already created a bunch of secrets. And the ones I'll be using today are Python DB user and Python DB password. And I'll go ahead and open up the password one real quick. And down here in versions, once that loads up, I can see I have one version, and by giving it a right click and view secret value, I see that it contains the string password inside of it. Great. Okay, so now I need to call this though. So what I will do is I will add a function. This is the access secret version function, and in it, it takes the resource ID of a secret manager secrets version. And in here, I'm going to import secret manager, and then I'm going to access the client library by creating a client with my secret manager service. And then I am going to store a response, and in that response, I'm going to store the access secret version, and I'm going to get the version's value. And then I will decode it and return it. But let's add this now. So I'm going to copy this. I'm going to paste these up here. Oops. Okay, and then in here, we're going to have a string for our version ID. So I'm going to copy password here. Copy resource ID. I'm going to paste it into password here. And then I'm going to go /versions/1. And now we'll get the first version of this. And then I will copy this string here and do the same thing for the user, except I will make this DB user. And then I will hit save. So that's looking a lot more secure. I don't have my user's username and password exposed now. So let's go ahead and try and deploy this to the cloud, because I'm pretty sure this works. So I have created, with Cloud Code, I have created a Cloud Run deploy configuration. And I've selected my GCP project that I want to deploy to. And we're going to go to Cloud Run fully managed. And I'll just keep this US Central 1 region. I have my service name, which will be Python tabs space public, and I will allow unauthenticated invocations for this. But in my next example, I'll show the require authentication option. And where will my container be stored? I will be storing it in Google Container Registry, and then CPU allocation, setting all of this stuff up, very similar to when I was deploying to the emulator, which is by design. I'm passing in my Cloud SQL connection and my service account, very important. And I will hit apply, okay. Now let's try and deploy this to the cloud. Yep, and this will take a second here, so just hang tight. Okay, we are building. This is all building with Docker. Okay, and now we are deploying.
Hey, Abby, just in this time, let me ask you a quick question.
Yeah.
Where do you use secret manager and where do you use, say, environment variables?
Oh, secret manager versus environment variables. So with secret manager, it's great for accessing from your code. Like, I don't think, I was reading up on the documentation, and I believe it says it's not meant for environment variables.
Okay.
Yeah. Yeah.
Awesome. And
Yeah.
does secret manager handle the Flask app config variables too?
I'm not sure. You would have to programmatically do that from your code. So it is possible.
Okay. Awesome.
Yeah. Yeah.
I'll just head back then.
Okay, sounds good. All right, so we have now deployed to Cloud Run. We're in the cloud now. Let me open this up. Let's see if we got some goodness going on. It takes a second to start up the first time. Okay, looks like it worked out okay. We are now running on Cloud Run, and you can tell because the app is .run.app, that big URL up there. And let me just test out and see if the database connection works. I will do a vote for spaces. Okay, got 13 votes in there. Let's go back to PyCharm. Let's go to that votes table, and let's see if this changes to 31. And give that a refresh. Yes, change to 31. And there is my vote for spaces. Awesome. So that was a look at testing a Flask website locally in the Cloud Run emulator, and then deploying it to the cloud, but also connecting it to a Cloud SQL database and securing your database credentials with Secret Manager. Okie dokie. Now let's go back to the slides. My slides it. Okay, so this is the next example. Things are getting a little more interesting now. Now I'm going to use PubSub to trigger a Cloud Run service. Okay, so what exactly is PubSub though? If you aren't familiar, PubSub is an asynchronous messaging service that decouples services that produce events from services that process events. So you can use PubSub to push messages to your endpoint, which will be my Cloud Run URL, and where it can then process that message. Yeah, it's all about processing HTTP requests. And it's durable, and it has a real-time delivery and high availability, and it scales to your traffic. So at a high level, Cloud Pub Sub is a publisher subscriber service, hence the name. And publishers, as you can see in this diagram here, a publisher publishes a message to a topic. And then you can set a subscription on that topic. And my subscriber, which would be my Cloud Run service, can then subscribe to that topic through that subscription and receive that message that came from that publisher. So here it was a fun little example I made a while back, and this uses PubSub with Cloud Functions. Cloud Functions, you can see it as a baby version of Cloud Run. It's just one serverless function. So what it was a slash command in Slack. So when you did /doge and then passed in an image URL, I set up a webhook so that passed in that information to my Cloud function. Doge queue was what it was called. Then my function would publish to my Doge convert PubSub topic. And then when that message hit there, my other Cloud function would pull that message and then process that message and use the Vision API to run this little Doge picture through labels. And I could then determine that this picture of my little dog here is a mammal, a Shiba Inu, a vertebrate. So this was called Doja Chat, and basically it's a Dojifier of images. And then once you've processed it, you can return it back to the person who called the slash command. All right, but let's do a little simple example first. So what I'm going to do is I'm going to open up a terminal and then use the Cloud SDK to publish to my PubSub topic called demo topic. And for the sake of this demo, I have already created demo topic. And I'm going to pass in a message, and the message is all it's going to say is runner. And then it's going to hit my my PubSub topic, and then it's going to trigger my Cloud Run service, invoke it, if you will. So in the end, oh, my boxes got a little messed up, but in the end, my Cloud Run service is then going to log hello, and then the contents of that PubSub message. But let's take a look and see if we can make it happen. So here is a new little service, very small, not that big. So what's going to happen is when that message hits my Cloud Run service, I am going to grab its JSON contents and convert it into a dictionary. If there is nothing in there, I am going to say, no, bad request. And then it'll try and redo it over and over again. But you can set settings to not have it do that. Then I'm going to check if it's a dictionary, and I have to make sure there is a message in there. And if there isn't, I'm going to say, nope, no good. Then I'm going to create this PubSub message variable, and then I'm going to then grab the contents of my message. And actually, I'm going to show you what this looks like. Let me grab the link for that. I'll show you what the message looks like. So the message looks like this. Yep, so we're looking for message, and what we want is in this data here. And this data is encrypted with, I think it's base 64. Yep, base 64 encoded. But this is where our little runner message is going to be. So closing out of that, by default, I'll name it, I'll pass in world because, hello world. Then if it's a dictionary and we got some data in that PubSub message, I'm going to assign name equal to the decoded data in there, and then strip out any extra spaces, and then print hello runner and return a success message. Okay, let's see. Anything else we need to do? Okay, so the first thing I need to do is deploy this directly to the cloud because I need an endpoint to associate with my topics subscription. So I'll go ahead and deploy. Oh, and while I was deploying, I will show you the configurations for that because this one's a little different. So the service name is PubSub, and this time I will require authentication. So this means that when I access my service in a second, it won't let me see anything. But if I assign a service account to my subscription, PubSub can invoke my Cloud Run service and trigger this. So that's how you make it secure. Okay, and we're deploying. All right, so if I go ahead and hit this service now and put it over here, you can see forbidden. I don't got permission. So I'm gonna get out of here. And instead, I am going to show you what it's like setting up a push subscription. So I would do this through gcloud commands, but it's like it's a huge command. So I'm just gonna show you with nice UI. I'm gonna drag this over here. Okay, so I already have a pull subscription set up on my demo topic, but now I'm going to set a push subscription so that we can actually push this stuff to my Cloud Run service and invoke it. So I'm going to go ahead and give it a subscription ID name, and I'll call it Abby Carr demo topic sub. Looks good. I'm going to assign it my demo topic. Actually, this wasn't working earlier, so I'm just going to enter my topic in manually. Demo topic, subscription for demo topic. Now for delivery type, I am going to do a push subscription. And I need to give it my endpoint URL. So where's that at? Well, that's right here in my service URL. I'm going to copy that. Copy. Then I'm going to go back to here, and I'm going to paste this in. My service endpoint, and I'm going to enable authentication. So this will allow the subscription to actually invoke my Cloud Run service. And I'm going to give it my service account, which is Cloud Run Invoke. So this service account has the Cloud Run Invoke role on it already. So it's able to, now the subscription will be able to invoke my Cloud Run service. A lot of invoking going on. I'm going to skip all this stuff and hit create. Okie dokie. So now I have set up a push subscription. And let's get out of here. Now I need to test it out though. So I'm going to go to my terminal. And I'm going to use a command to publish the one that I showed in that picture, gcloud pub subtopics publish demo topic, and then I'm passing in my message runner. All right, and we got a message ID back, which means it was successful. And now I'm going to go ahead and open up my logs for my Cloud Run service and see if we saw what we need, if we saw that come through. Okay, and down here, down below, oh, mail, boom, boom, okay. Down below, we see that we have hello runner. So we have successfully triggered this Cloud Run service with PubSub. Whoa, but that was a pretty basic example. I feel like we can beef this up a bit and make it more exciting. So I am going to go ahead and go back to my slides. Okay, so let's now turn this into an async image processor. My notes. Okay, so what's going to happen here? I am going to upload a picture of a violent picture to a cloud storage bucket named Abby Carr new images. Then I'm going to set up a notification when new images get uploaded to the storage bucket to then hit my PubSub topic. So I'm going to send a message to PubSub, and then my Cloud Run service, it still has that subscription on it that I set up 2 seconds ago. And I'm going to expand my little Flask service to then analyze and blur any violent or adult images. And then once I blur it up using image magic, I'm going to store it into a different cloud storage bucket named Abby Carr blurred images. Okay, let's see if we can make this happen. This is where everything can go wrong. So going back into here, I am going to create a new Python file. And I'm going to name this image. So we got image.py now. And I'm going to do some imports here. I'm going to first import OS, and then I'm going to import temp file because we're going to be needing to make a temporary file. Now I'm going to import cloud storage and cloud vision. Google.cloud import storage, comma, vision. And then going down below from wand.image import image to use image magic. Okay, and then I will set up my clients, so storage client, so we can actually work with this API, equals storage.client, and then vision client equals vision.image annotator client. We're going to use this to analyze our image. All right, but going back to my Docker file, I need to include image magic. So I've already done that here. And all this does is it installs image magic so I can use it. Back in my image file. Okay, so now I need to make a function that is going to analyze the image. So I'm going to go ahead and do blur offensive image. So what this function is going to do, and I will walk through it, is first, we're going to get that data from the message. And the data is going to look like, let me show you the resource. The data is going to look like this. So this is coming from cloud storage. And this is a lot of stuff, a lot of information, but all I care about right now is the name and the bucket, because with these two pieces of information, I can create a resource identifier and access my image once it's in my bucket. Close that out. So now I'm going to store that data into file data and then make a file name and bucket name and grab those pieces of information. Then I'm going to grab the blob of the uploaded image using my storage client.bucket, and then I'm going to put in my bucket name .get, and I'm going to get that file. It's just a wrapper around there. Then for blob URI, I'm going to craft it up. So it's a gs:// looking URL URI thing. And then I'm going to then use this cloud storage URI over here to then create an image with the image API to analyze. And now we're going to start the analysis. So my result, what's going to go in my result here? So I'm going to call my vision client, and then I am going to use the safe search detection on it. And what safe search does is it's what is going to be looking at the image and determining if it's violent, if there's any sort of like nudity in it or any sort of weird stuff like that. And then, yes, so it's going to analyze that. And then I'm going to store the results in detected and then grab the information out of there. So if we detected adult content and the adult content is 5, 5 means very likely that this is adult content. And this goes from a scale of 0 to 5, 0 being I don't know, unknown, to 5 being this is probably definitely adult content. And we're going to do the same thing with violence because that's going to trigger our zombie. All right, and then we're going to print that we've detected an inappropriate picture, and I'm going to run a blur image function on it. All right, now time for another function. So we're going to run blur image. So blur image is going to take that blob, and we're going to now use image magic to, we're going to create a new file, a temporary file here. Okay, so we're going to create a temporary file, and then we are going to download that blob and stick it into the temporary file. Then I'm going to use my image and run image magic on it to then blur it using hamming. So this is gonna, zero blur. Let's see here. So where anything greater than 1 is gonna blur it. So this is gonna get pretty blurry. And then I'm gonna save my temporary file. And I'm gonna print that it was blurred. And I need to give a bucket name. And I think my bucket name was, this is where I'm going to store my blurred images. And I'm gonna get my bucket, get some context there. And I'm going to make a new blob. And I'm going to pass in the file name. So we're going to keep the same file name when we put it into the blurred cloud storage bucket. And then I am going to now upload the contents of that temporary file that I was doing all the blurring on to cloud storage. And then I'm just going to remove it from my OS because you don't want to fill up that temporary storage in here. Adding a new line and save. So that looks good there. In my main.py, I do need to make a tweak here. And let's see. All right, so I'm going to remove this whole bottom half here because it's no longer relevant. And I'm going to do call blur. Okay, actually, I think the indenting is a little off. I'm gonna grab this and let's back it up a bit. Okay, that's looking good now. Now let's walk through it. So what's gonna happen here is I am going to load up the contents of that cloud storage request I showed you, and then I'm going to decode that data. And we have a bunch of error handling going on here. So if it wasn't proper JSON, it's going to be a 400 error. If, let's see here. And then once it passes all my error checks, I'm going to try to blur my image. And I'm going to go ahead and import image. So we can call blur offensive images. And then I think this needs to be tabbed over. All right. And if that doesn't get hit and we can't return a success, we are going to say no good. All right, so I think that is everything I need to do. Just double check in here. All right, let's save this. And now I'm going to deploy this. Fingers crossed there's no errors in there. I don't think so. Okay. Okay, now we are building and deploying again. Yeah, this is where the demo gets a little high stakes. I don't know if I could have had a typo somewhere. Let's hope not. Okay, now we're deploying the container to Cloud Run. Okay, looks like that deployed. Now, what I'm going to do is go over to my terminal, and I am going to use gsutil, which is a Python cloud storage command line tool, to create a notification on my cloud storage bucket to trigger pub/sub when something new gets added to it. So I'm going to use this command here, gsutil notification create, tell it my pub/sub topic, and then tell it my bucket, which is abbycar new images. So when a new image comes in, let's set up a notification. All right, so notification has been set. And where am I at right now? So I'm going to go to CD to my pictures folder. And then I already have my zombie picture in here. So I am going to use gsutil to then upload an image to cloud store to my bucket, which is zombie.jpg. All right, and it looks like it uploaded. Now, the moment of truth is to see if our Cloud Run service logged some information about what just happened. Okie dokie. So let's go down. Okay. It looks like it worked okay. Looks like we were analyzing the zombie picture and the image was blurred. Let's close out of there.
Hello, everybody. It seems that we've lost Abby. We're just going to wait for a little bit for Abby to come back. We've actually had quite a few questions that have come up. So the first of it is, and this is something that Abby has helped in answering. So, does code work in PHP Storm? Actually, it does. It works in multiple IDEs. Um, so, uh, Pretty much any IntelliJ IDE should have support for it. Can you have access to this code later on? Absolutely. You can definitely have access to all of this code later on. It will be made available in public on a GitHub repo. After that, we have, does the secret manager handle the Flask app config variables too? Yes, it does. So the secret manager can be used to set any environment variable, and Flask can be configured to take its configuration from the same environment variables. But anything that does not actually need protection, you can add them as regular environment variables when deploying. Um, does Cloud Code generate the initial Docker file when you open up a Cloud Code um, project in PyCharm? Yes, it does, and it generates a very basic Docker file. But you can feel free to edit it just like any other Docker file. You can, sudo yum install anything that you might need. After that, we got a question. Is it possible to run a Dart application on Google Cloud? Absolutely. So anything that you can containerize, you can run on Google Cloud Run. So you can totally do that. And is it possible to use a local database, or does it have to be cloud based? I think it has to be cloud based. So the thing is, the way that Google works is that the different services have to connect to each other, and you need a secure connection in order to do that. Because they're services, you can also control what services have access to what other services. So, for example, a Cloud Run application can have only access to, say, a particular MySQL or Postgres database, but not to, say, something else in that, not to, say, for example, a spanner database that it doesn't need to talk to. We also got a question about, does PubSub provide a Kafka-like interface? Yes, it does. It does provide a Kafka-like interface, and it is fully managed. So you can completely use this as a managed service as well. Um, Another question that we got is, do you need to install Google Cloud SDK? Yes, you do. So the way that Cloud Code works for Google Cloud Code is that it most of the time manages to download the SDK for you, but sometimes things go wrong. And so it's better that you directly install all this stuff that you need directly. And lastly, does Cloud Code have debug support? From what I know, that's in the works. So hopefully we will have that sometime soon. Um, so we're just going to work on, we're just going to see if Abby can come back. But folks, if you
Oh,
have any questions, please let me know. Hey, Abby, you're back.
okay. Sorry, I'm back. My internet just shut down, and I'm tethered with my phone right now.
Hey, that happens
Yeah,
to the best of us. So,
yeah.
did your bucket thing actually work? Or did you blur your image?
Yes. Is it too late for me to show it?
No, it's not. Go ahead.
Okay, okay. Let me go ahead and share my screen. My goodness. Sorry. I was like on a roll, and now I just broke my flow. Okay, here we go. Share. All right. Can everyone see that? Okay. I'm assuming yes. Okay, so I'm gonna go ahead and let's go and look at cloud storage. Oh, let me hide this. All right, so let's go see if I have a new image in there. And I have my zombie image, and we can see that that was uploaded okay with gsutil. Very graphic. Now let's go back. And then I'm going to check my blurred bucket, and let's hope there's something in there. My little hotspot's doing overtime right now. Okay, I see we got a zombie in here. Let's hope it's blurred. Oh no, my internet's going so slow. Okay, and there's a blurred image in here, and I'm going to open it. Let's see. There it is. This is my beautiful bird graphic zombie picture. And so that worked. We triggered with PubSub, uploading a new image to cloud storage, triggered PubSub, and then it took that new image's data, processed it in my Flask Cloud Run service with Image Magic, and then re-uploaded it after blurring it to a different bucket. And now I'm going to go back to my slides. Where are my slides at? Oh, right here. And I will leave you with this conclusion slide. So I encourage you to install Cloud Code into PyCharm and maybe give Cloud Run a try. We make it pretty easy. And yeah, there's just a whole lot you can do, you know? With Flask, the world is your oyster. And with Cloud Run, there's even more oysters. And that's it.
That was just brilliant, honestly. I learned a lot. I didn't know that you could blur stuff like that using Google APIs, but that was super cool. To
Yeah.
close
Oh, that's
things off,
actually with Image Magic. Yeah.
yeah, that's awesome.
Yeah.
So
Yeah.
just to close things off, just one last question before we close things off. Is PubSub something that you can use for Android app notifications? Because I answered a lot of your questions, so I thought I'd give you one last one.
Oh, thank you. Thank you. For Android notifications, that is not something that I have explored before, but anything that generates an HTTP request will be able to work with PubSub.
Awesome. Well,
Yes.
folks, thank you so much for joining, and thank you, Abby, for coming on. That was a real hiccup right there, but it was
I know,
awesome. You just
sorry.
got back in there.
Yeah, I know. Man, I was like so in the zone. I was very sad when it cut out, but I'm glad my phone pulled through. Thank you,
Okay.
hotspots.
Yes, absolutely. So, all right, everybody, thank you for your questions. We'll make sure to have a follow-up blog post after this to give you access to all the code and answer any of the questions that we didn't get to answer this time around. And always, thank you so much for everything, Abby and the audience. All right, then.
Yeah.
See y'all later.
Thanks for watching.
Bye.
Bye.